SwayamPrabha. Digital India. Educated India.
Hello everyone, welcome to Groundwater Hydrology and Management NPTEL course. This is week 2, lecture 3. In this, we are looking at the importance of groundwater resources both internationally and nationally. To better understand and manage groundwater, it is very important to estimate where groundwater is used more and what are the chief uses for the groundwater. Also, it is important to understand which countries are consuming more groundwater and also what are the plans and management activities they are undergoing. We are still in the past 2 lectures looking at the stress on the groundwater system. So let's continue with that discussion and notes. In the last class, we looked at this slide by the end, where we looked at water stress and groundwater. So this data, which is on water index, is made by WRI in 2013. And you could see red colors indicating extremely high stress on water resources, regions with extremely high stress. No data is where they could not collect data, whereas the yellow is low stress and low to medium would be in the orange color. So just looking at the baseline water stress, the current scenario where the water stress is high, you could see most of the water stress in the Asian region, especially in India, Afghanistan, Iran, those kind of regions, and also along the agricultural belt, Thailand, etc. You also see a lot of water stress in the African region, both in the north and south, and European context, along with the developed nations of US, Canada, and Australia. Pockets, very small pockets. The extremely high water stress is mapped along the Indian subcontinent, where groundwater and water resources are heavily used to supply water for the big population and also for agricultural and industrial activities. So if you map the groundwater uses that we looked at in the previous lectures, you could clearly see that the water stress already mapped across the globe also mimics your groundwater use. So why would someone spend energy and take groundwater is when you have water stress. So if a region has good groundwater resources, they won't use it until there is a stress. For example, you have good dams and connections to water that you see in US and Chinese regions. You don't see much water stress. So only when the water is not enough, you would spend energy, either electric energy, diesel pumps, fossil fuel burning pumps, solar energy to extract groundwater. So the water stress and groundwater go together hand in hand to explain that people would go to extremes and also costly methods to get water, because that is what drives the economy. If it is agricultural nations, example, India, Vietnam, those kind of countries, and or for development, industrial development like China, US, etc. If you look at US, even there, you have a lot of agricultural activity on the southwestern part, California, and there you could see a lot of water stress and also groundwater use. So all these clearly indicate that wherever there's a water stress, either the government or the locals would extend their groundwater use to tackle the groundwater issues. This actually cumulatively impacts your groundwater sustainable use. let's see how these global groundwater change occurs. So we've looked at water stress, and we're going to look at the major aquifers and how the annual groundwater change is. So this data from the Earth Observatory of NASA clearly documents that the annual change in groundwater is really concerning in most of the major aquifers across the world. About one third of Earth's large groundwater basins, or aquifers as we call them in groundwater terminology, are rapidly depleted, and mostly for anthropogenic use. Humans consume it for domestic use, industrial use, or agricultural use. There is very less data because not all regions are monitored by observation wells. So this study from NASA uses satellites. It's a very novel and very high-tech use of satellites to monitor groundwater. We will discuss that when we come to tools for groundwater estimation. Here, the study results clearly show that most of the big aquifers, one third of the big aquifers across the globe, are highly stressed. The annual change in groundwater is in negative. So negative is represented by brown color. And what it means that every year your groundwater is coming down. There's no recharge. There's no going up in the ladder. So the volumes where you see the positives are mostly in Australia, some parts of Africa, and regions of North and South America, where agriculture is happening, I would say. The other regions are not that of much of interest because in these parts, not much agricultural activity happens. Remember, we discussed the groundwater economies, socio-economies. Here, there's not much in Canada and Russia groundwater used for agriculture. So let's focus on the regions where groundwater is used for agriculture. And you could clearly see that the major aquifers that are giving water for agriculture are highly stressed. And as a result, every year your groundwater comes down. Is this sustainable? Certainly not. Because you are think about the analogy I use for a bank account. You're continuously taking amount without putting it back. So how much can you take? Only until you run out of the groundwater. Okay, and once you run out, it is going to be disastrous. So it is very, very important for groundwater management. And this image clearly shows you where the hotspots are for groundwater depletion, especially in Asian regions and along the regions where there's less rainfall, like Middle Eastern, African regions, etc. There's still less amount of data. So this also is urging for policymakers and scientists to collect more observation data to better monitor groundwater use. So the annual change in millimeter thickness of groundwater, I'll explain the units later, is in the negative. So you compare the previous year to this year, already minus 20 millimeters in India. Then you go on and on. If you want the volume, you can multiply it by the area to get the volume. So it is equivalent water thickness is tremendously falling down. Moving on from another study by IGRAC, the previous NASA study was in 2015. This one, IGRAC, is an international organization for groundwater studies, also shows a similar pattern in 2014. What they've done is they've taken a year, 2010 as the study year, and developed a groundwater development stress map. So where the groundwater development and stress is happening a lot, and you could see that is made by using the two values. One is abstraction and the annual recharge. So you have your bank account, you know how much money is coming in and how much you're taking out, including all the users. Okay. So that is what they've done here in this example, and they've mapped it across the globe as continents and national boundaries. What you clearly see is the abstraction rate is really, really concerning in the Asian region, and all the less than 2% of annual recharge is very, very good, which means you're not up abusing your groundwater, you're not using much. And 2 to 20% is also pretty good. Until 50%, no problem. Okay, so if you look at the light brown colors, up to 50%, there's not much problem. And the up to 20%, the governments should look at how can you better access this groundwater for a better economic development, let's say Africa. So as I said, there's a lot of groundwater here, a lot of recharge happening, but not much groundwater use. So can you think of activities where you could put in some groundwater networks for better water use for sanitation, health, and other economic activities, agriculture, livestock, etc. But since this is a course on groundwater management, we have to discuss on the stresses, on where the concern is. So if you go to the darker brown colors of 50 to 100%, you could see the countries which are using more than actually what is coming in. So basically, you are using water that has been stored for years and centuries because you're already taking out all the annual groundwater and you're eating into the reserves or something that you save for a long time. So India would come under the 100% almost range. And if you break it into states, you'll see some states will go above and beyond the 100%, which is really, really concerning. So in this map, you see the northern parts of Africa, Middle Eastern countries, Afghanistan, Iran, Pakistan, all extracting more water than they get. So basically, they're extracting water from the previous years and historic groundwater, as we call it. Whereas India, it's on average, it is between 50 to 100% of the groundwater, according to this study, which is also very concerning because you're not leaving any groundwater for the next year. Suppose the next year is a flood year, a good rainfall year, then there are three scenarios. The next year could be a good rainfall year, a good flood year with a lot of water, and a drought year. So these are the three basic scenarios. If it is a good rainfall year, your recharge is happening, so you're not worried too much because you extracted, and the next year water comes in, fine. In a flood year, not all the water will go into your aquifer because big floods will carry the water out of your watershed, not enough time for recharge. So that is a very concerning situation. Moving on, we have the other as a drought, which is the most common stress during climate change. What happens? So you've already taken 100% of your groundwater that has been recharged. So you don't have much water for the next year where there's a big stress and not much annual recharge happening. So suddenly you will have to change how you use groundwater and or how do you manage groundwater. That aspect is very, very important for better groundwater management. So India ranks right there out of 50 to 100%, which means we are seeing climate change extremes of droughts and floods. And if we don't manage the groundwater, the next years you will not have enough groundwater for sustaining your activities, sustaining your agriculture, or even drinking water supply. So it is very important to manage them. Another study, very coincidentally, so that this was done by IGRAC in 2014, and the previous was done by NASA in 2015. Another study by Ritchie et al., also using the NASA collaborators, showed that 1/3 of groundwater basins are in distress. Similar findings, and what you've noticed here is that the labeling of where these aquifers are, the major aquifers. For example, let's take it from the Indian region. Number 23 is the Indus Basin. It is in the negative, okay? So which means every year your groundwater is depleting. So right from your yellow, it is all in the negative, still red. And white to 25, which is the blue, is okay. So blue means it is recharging, which is fine. So if you look at where the positives are happening, Central Australia, Northern Russia, parts of Canada and US and South America, where not much of agricultural use is happening in these regions, even Africa. When you come to the yellow and orange regions where it is depleting but not as drastically, is still a big concern. You could see the Indus region here. The number 23 Indus Basin is depleting faster, along with number 29, which is the North China Aquifer System, and number 33, which is your Russian platform basins. Okay, so all these are pretty concerning in terms of it is a warning bell. You would need to start better managing the groundwater. Number 22, including which is the Arabian Aquifer System. All these are warning bells that you need to stop using how you're using groundwater because you're already taking more than what is coming in. Okay, you are in the negatives. If you don't, then it will become red or very, very highly warning situation, such as that exhibited in the Ganges water basin and Brahmaputra, which is under 24. So Ganges Brahmaputra basin, you could see it is in red color along Nepal, parts of China and Tibet, India, Bangladesh. All are facing tremendous groundwater extraction and because of that groundwater stress, along with number 34 basin, which is the North Caucasus basin. These are the major basins which are highly, highly under distress, minus 20 millimeters of equal water thickness per year. So now you see a spatial distribution of where these water resources are major in the groundwater basins. And also you can clearly see where the groundwater aquifers are highly depleting. Now, if you compare this with your previous lectures, typical crops that they grow, you can clearly understand that the crops that they grow are not going to be sustainable. Especially, let's take India here, for example. We looked at rice, wheat, and other crops. So if we just look at rice and wheat and sugarcane, this constituted around 75% of the groundwater that we use. And that is not going to be sustainable as per this figure's estimates of groundwater depletion. Every year, groundwater is depleting. So if you don't stop and reorganize yourself, then the groundwater system is going to be lost. You will not be able to grow your sugarcane, wheat, and rice as you were growing. This could lead to equity issues because not all farmers have access to groundwater, and not all farmers can spend more money to dig deeper and have high energy pumps, high efficiency pumps to be used for agriculture. Okay. So this is where a lot of equity and poor and rich farmer divide is going to happen. It is very important to understand where these aquifers are, what are they growing in the aquifers, and is the volume rechargeable? Minus 20 is very hard to bring it back to zero annual change, and how are we going to do it? So how do we do it? By the introduction of some policy and governance. We could quickly look across the world where they have introduced these policies and how they are different when it comes to groundwater management. So here you can quickly look at where the major aquifers are and major depletions are happening, and we could compare that with the instruments of groundwater governance deployed in these major irrigation countries. What we saw is Australia is a major irrigation country using groundwater. They don't have groundwater pricing or any type of metering to estimate groundwater as per in 2014. There are some entitlements, which means they would legalize certain people to use groundwater. So entitlements are given. And administrative regulations are there. There'll be some checking and monitoring of these groundwater, but there's no pricing. So there is some regulations, but not much pricing. There's no community management or recharge development, and indirect approaches are not present. So and also they're not much concerned because Australia's groundwater resources, as per the previous figure, are not much depleted or in the red zone. When you come to Bangladesh, which is in the red zone for sure, there are meters present. So meters are being present in the country to monitor the groundwater use, which is a very important step in identifying equitable share and where the groundwater is going. The others are not present. The other mechanisms are not present. If you come to China, yes, groundwater pricing is there. So consumers have to pay as per the unit of groundwater they use. And the use is also given, guided by administrative regulations, entitlements, and also a lot of community management is happening. I'll come to India as the last so that we can discuss more. But Iran and Jordan work similarly. They have meters for groundwater use and they price it per volume used, which is governed by some administrative regulations. And Mexico is guided by entitlements. Only some people can use groundwater, or you have to get permission, and that is also being metered with some community management. Oman, Pakistan, Spain also follow administrative regulations and also work on collective recharge methods. US, which is the another big country using groundwater, are not allowing everyone to put in groundwater. You cannot casually put groundwater. You need to get entitlements, and also it has to go through the government where you want to put the wells, how much water you want to use. There's no pricing, but it has to be through regulated government entitlements, and there are some community and recharge enhancement methods to increase the fresh water in these aquifers. Now, coming to India, there is no groundwater pricing. We have more than 20 million wells. So think about you're going to price or meter all the wells. It's going to be really expensive, really time consuming, and also will lead to a lot of sensitive issues like in estimating who's using more water, and is it accurate readings, and those kind of issues will happen. It's not as easy as just monitoring the power because groundwater is not readily converted to your crop output, because your crop might not grow for various reasons, but it can be blamed on groundwater. It's like fertility, water loss during application of groundwater, all these issues. Okay, so because of that, there is no groundwater pricing. If you go across India, you will not find groundwater pricing for irrigation nor domestic use. There's no entitlements, which means everyone has the right to put in a groundwater, farmers I'm saying, and they can pick a location in their own farm, they put it, or they have a community well with an agreement with the villagers and or the community, which means 4 farmers can come together and then put in a well. So those entitlements are not needed in India. There's no administrative regulations, which means if there are 2 farmers, 2 different wells, there's no regulation on what depth the well should be, and there's no regulation on what volume farmer A should pump and farmer B. So for example, farmer A can pump more than 20,000 cubic meters per year, whereas farmer B cannot afford that much power, and he or she just pumps 1,000 cubic meter per year. There's big difference because there's no regulation. However, if there's regulations like in the US, it is set at a particular rate and you cannot go above it. You can come below it, which is fine, but if you go above it, you'll have to pay extra or shut down your license for groundwater. So in India, that is not available, and this has led to unsustainable use, and also it is becoming harder to monitor which areas exactly are using more groundwater. So for example, if I can take a village boundary, there are multiple wells in the village. It's very hard to distinguish who has more extracted more water because there is no metering, and they don't follow the rules on I will use water only at this time. Also, if the power that is needed for groundwater extraction is given at a very low cost, what would happen is sometimes the farmers would pump more than what is needed, and the water will either go down into the aquifer or get evaporated, which is a loss to the system. Okay, so that's where the regulations and entitlements could help, but it's very complex to get them implemented. And because of that, there are community aquifer management programs. It depends on where these schemes are introduced. For example, there's a scheme called MARVI, Managed Aquifer Recharge through Village Level Interventions, where the community comes together. They manage the groundwater in Saurashtra region, Dartha, etc., and they properly document what can constitute a good sustainable groundwater use plan that all the villages accept to agree to use in their system. Also, they have a recharge enhancement or conjugative groundwater surface water management plans. Something as an example is given in the Saurashtra recharge movement. Also, indirect approaches are there, which is an example of Gujarat's Jyotigram. So all these progressive states or states that value groundwater more, they have put in a lot of measures to actually increase the groundwater, reduce the consumption, and also monitor the groundwater use. The governments have also noticed that it is going to be difficult for a government agency to set up these regulations. However, if you train the community also knows how much water is available, and the community can decide as a unit where the water should be and how the water should be. For example, if you have a government regulating you that you should only use 1,000 m³ per well per year, and two farmers are there and they don't agree because they cannot grow what they want, then there is disharmony. Then the plan will flop. But if a community comes together, for example, all the farmers in a particular village, they come together and assess the situation. This is how much groundwater we have, and all of us will collectively grow only mustard. This year, we will not grow cotton or sugarcane. It will need more groundwater, and we will not grow it for the benefit of the village. So all the villages will grow mustard, conserve the groundwater, and use it for the next year, provided there's good benefits. So this mechanism is kind of the community use of groundwater. And when they use also, they also do some aquifer management plans, wherein they construct bunds and other natural types to recharge the groundwater, catch the surface water, and then recharge it into the ground. So you could see that India groundwater use scenario is changing, at least in the management aspect, but much more is needed because the volume that we extract is at a very large pace. And so for this, it is very important to understand the groundwater availability in India. And for this, I am going to discuss the Central Groundwater Board data, which is the predominant groundwater monitoring agency in India. And what you can see here is there are different basins in India, and the key basins are the Brahmaputra, Indus, and Ganges basin. The first column talks about the basin names, whereas the next column looks at how much groundwater is actually being recharged, and then out of that, how much is being used for domestic industrial uses comparatively. And then if you subtract both after your domestic and industrial use, most of it is available for your irrigation, but only X amount, for number 6 column, only some amount of number 5 is used for irrigation. It could be because they don't need it, or they don't have the resources to extract the groundwater. Moving on, then we look at how much is remaining. So number 7 is how much is remaining for groundwater use, and the level of development is the ratio of water available to the balanced water. So what you see is the ratio here. The last column represents the total replenishable water and the how much water is actually being used, level of groundwater development. So only 3%, which is used in the Brahmaputra basin. Okay, so you have a lot of excess water remaining, which is also shown here as balance, number 7 column. So let's see quickly how do you come to these numbers. So 3 is your recharge, which is estimated from the rainfall and geology. Number 4 is based on your number of industries and population. available for irrigation is just a subtraction of 3 minus 4, which gives you 5. And then the net draft is how much water is actually used as per the irrigation and agriculture departments. And if number 7 is just basically 5 minus 6. So the percentage of groundwater development, or how much is extracted, is the ratio of the total available for irrigation or for the total replenishable groundwater, and how much draft, the total draft which is being used. Okay. So it is only 3% in the Brahmaputra basin. Let's neglect the smaller basins in terms of percentage of development. As we notice, anywhere from 20 to 50 is on the borderline of being concerned. So if you look at that, 20 to 50, Kambai Composite, the Kaveri Basin, the Ganges Basin are all under the 20 to 50 almost region, the Kutch, Saurashtra region, etc. The concern is when you go above and beyond it. For example, the Indus Basin. As we clearly saw, both the Indus on the Pakistan side and India side are tremendously exploited for groundwater. And as a result, in the Indian side, we see 77% of the water is being used. And most of the water, if you look at the numbers, is being used for agriculture. So out of the 26,000 million cubic meter per year, you are using around 18,000 million cubic meter per year. That is around 77% of groundwater development. Moving on, you also see around 57% in the Madras and Southern Basin. And also I can include here again the Kaveri Basin, which is at 55%. So at a basin scale, these are the different numbers, but when you break it into blocks and districts and state, you will see a different picture, because every state will have their own groundwater use preferences, and also based on the population and agriculture, the groundwater use will be different. So with this introduction to availability of groundwater in India, I will move in the next lecture to discuss the groundwater per block, how much it is, and what are the issues and concerns right now where we need to put in more effort for groundwater management. I will see you in the next class on the same lines to discuss issues on groundwater for India. So over the past couple of days, we are looking at mostly the importance of groundwater internationally, and then we slowly moved into the subcontinent and Asian regions, and now we're moving into the Indian context of groundwater issues and concerns. I'll see you in the next class. Thank you.